उत्तर पूर्व द्राविड़ कर्नाटक तेलंगाना आंध्रा केरला उत्कल बंगा विंध्य हिमाचल तावी यमुना गंगा सरस्वती कृष्णा ब्रह्मपुत्रा उच्छल जल्दी तिरंगा। तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जयो गाथा सर्वधर्म नागरिक भारत विधाता। जनगण मंगल अधिनायक जय हे भारत संविधान भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे। जय भारत वंदे मातरम। Excellent, dear friends. This is again back to you, Suraj Singh, my introduction. Before going further, this is fellowship, fellow certification, and this is charter engineer certification. Continuing talk of field management, which is very important one from my point of view and from your point of view. Field engineering, very important subject. We all directly or indirectly deal with activities conducted in field of construction one way or other every day. Starting or budding engineers, freshers, senior engineers and veterans, whether in design or in construction field, they are exposed to varieties of activities. At some point of time, everybody works as site engineer and all site engineers at some point of work as managers. Various categories of roles we have to dispose in our civil engineering field and also interdisciplinary fields such as HVAC, electrical, mechanical and IT and security. Various fields we are involved with. It's not easy job. It's of course very difficult job because we have to contribute energies physically as well as mentally. Not so easy, very difficult, but engineering dedication, work dedication and nation building and international building dedication force us and expect of us to dispose of such responsibilities on an entire basis, not only on scope basis. We are responsible as civil engineers for building society, for changing society, because engineers are generally called agents of change, and agents of change means social change and all other changes, because social change includes every change, and we are ourselves always ready to accept changes, amendments and modifications in our field as well as in interdisciplinary fields. And that is our, you can say, beauty of profession, that we are not just say that we are laki ke fakir. We are not followers of lines. We make our lines, make our fronts, we open everything to society, and that is where engineer stands, and that is where role of engineer stands, and that is where profession stands. Profession may be recognized by government or may not be recognized by statute. It doesn't make a difference. Ultimately, you have to work in profession. You contribute to profession because you are bound to do that. But question is not that. Question is that to what extent We stand dedicated to that. We stand devoted to that. How much we research ourselves, our acts, what we should have done and what we have done. A comparison. Just because it was done, I am doing. That is not a requirement. Engineer means thinker. Just remember. An engineer means a person who is genius. And genius, this genius character, genius property is not filled in. It's natural. Only requirement is, only point is that you have to pick it up. Everybody builds its work, everybody builds everything. But it's not copying and paste. We don't want to copy and paste. We want to generate. We have to generate every new act, every new design. We have to generate every new method. Not because we want copyright or design right. We want production right. Production itself is our design. Production itself is our quality. Production itself announces that there has been something extraordinary. That's what we have to understand. Engineering cannot be defined only design and production. Engineering means use of mind. Engineering means application of mind. Engineering means bringing on ground what you think of, what you contemplate, and modify that, amend that to best use of humankind. That is engineering. Use your entire genius value to production for world benefit. That is engineering. It's of course applied science, but that is to some extent. It's the genuinity, is an art, of course scientific art. We have to think and produce. We have to bring dreams to practical existence. That is engineering. This means role of engineers is very widened, unlimited, no vistas. You have to go to sky and do engineering. You have a vision, apply that. That is engineering. I am inclined to talk about field engineering, civil field engineering, which includes electrical engineering, which includes mechanical engineering, HVAC engineering, IT to some extent, security and building management, and many more. Fire suppression, wind controls, earthquake controls, rock controls, earth controls. So many controls are there. Quality controls, safety controls, planning controls, cost controls, budget controls. Not one, not two, as many as you can say. And we have as many activities as you can think. Sometimes 10, sometimes 100, sometimes thousands. Depends upon what type of projects we have. Generally, projects are done by contracting, by designing, and by promotion. Three aspects are involved. Promotion is done by those who have finances and those who own liabilities of all the consequences of that project, and that party is known as promoter. Other one is a party which is technical, which is learned, which is professional, and that party is called engineer. That party designs for that finance, for development of society, designs, conceives, and supervises, monitors works done by party that constructs. A party that constructs that imagination, that party is called contracting party. So these three are main parties who are directly involved, and these are supported by many other parties. And promoter who is responsible for this, that promoter constructs a charter of project which defines everything from zero to finishings, delivery. That charter contains all details of stakeholders, all details of input and all details of expected output. That is definite charter of project. It is called in management language charter of project, and it's very big, voluminous, not in one volume, in many volumes. Engineer's job is same. Constructor is a constructor, contractor, constructor, whatever you can call it. And there are the many supports from top and from below, from left and from right. Project is supported by various professionals and skilled and semi-skilled and unskilled, all categories of personnel which give shape to project building and consequential delivery. That point should be very clear. And as I explained before, generally we deal on such projects in form of lump sum contracts, lump sum budget, lump sum awards, lump sum considerations. Promoter or owner or employer, you may say, awards contract to contracting party on construction contract, supported by complete technicalities, complete commercial, complete, you can say, liability details, designs provided by engineer professional. So these two parties on each, on one, engineer and promoter, combinedly respond to management, and promoter and contractor combinedly produce delivery of construction and use of project, maintenance of project. These two parties are responsible and they have certain defined organizations for support. Those we have discussed. There are from engineer, on behalf of engineer himself responsible for technical, for economical and for all other aspects of project, budget controls, whereas got certain organization hierarchy where practical responsibility shared by resident engineer with assistance of many specialists and associates, and in online practical supervisors or clerk of work. Whereas on contracting side, end lies lead by project manager or site agent, supported by site engineers, project coordinators and many more, up to line management of foremen. These are basic hierarchies organizational team work for a project. On here lies main role, prime role of engineer, or you can say working engineer, functional engineer in construction, and that's called site engineer. Site engineer doesn't mean designation site engineer. Site means role of site engineer. It may be a project manager, or it may be a foreman, it may be a supervisor, or it may be project coordinators. All of them share responsibility. Sometimes, some point of site engineer. That is where I am interested to corroborate your knowledge, and that is very important. Whereas other part is, that is engineering group, which is responsible for monitoring, supervising, surveillance of all activities conducted by contractor, delivered by contractor. This is where we want to immerse in to understand role of all these professionals. And also management, project management, which I cannot limit to PMP or something, because it is practical, unlimited, vistar. You cannot define this in book form, because every project has varying degree of application of management knowledge that must be well understood. In a streaming board, it always keeps on streaming, it never stops. You cannot say that this point we start and this point we end, because every activity is a stream of different discipline, and that cannot be, you can say, lineated or delineated, that this is just a spectrum. There are various stages in every on every project where we have to do differently in a different way, and that is what management is all about. And this management, I was talking about management, what management is, and I have defined to you what about management. Actually, this management has been produced in relation to earthquake, where role of site engineer is defined, you can say briefed, and it is for prevention, capacity building approach, where I say earthquake management. Earthquake is specific here because earthquake is very serious part, though it is general management of buildings or structures, in which I included value engineering, which I had defined. I can again redefine it because this is very important for refreshing viewpoint. So what is value engineering? I should say, you may ask it that it is about cost or it is about quality or quantity. I am not stopping at that point. I say something else and I say answer is no to what I said. It's none of these. It's having entirely a different industrial meaning and a fine understanding of its construction, which is a must for personnel belonging to all relevant parties involved on projects. In civil engineering field, there is no limit on activities in all sections, be it designs, be it construction, be it supervision, be it office work or site work. All engineers would carry out work according to requirements as specified. Contractor would do job to contract requirements. There would be no value on expected level of performance. Quality system shall have to be complied with. Whatever accountable professional has to carry out whatever job normally, but when some job is done based on additional thoughts or additional research based performance, enriching grade of product in terms of superior quality at cost of normal budget, saving on cost of project, saving quantities of expensive material, saving contract time based on superior alternatives, excellent methods, alternatives than usual, presenting project with added service life, allowing better use, flexibility on designs, inducing environment friendly provisions, adding green use capability of building by saving energy consumptions, allowing various other benefits for use or client at or some or normal cost without risking safety by thoughtful approach adoption. These benefits amount to value addition on project at in any form, project proposal or ways, normal one or conventional bids. This especially introduce quality of performance amounts to be term value engineering, which applies to all parties involved on whatever project. It's not limited one, it can be anyone, whatever. As specialist working on project should add values to these projects. Owner has a right to expect best product out of monies spent. Work should be awarded to contracting party who corroborates offer to work and produce project with value engineering. Exclusive price comparison is not suggested to be made an exclusive basis for deciding whatever contract. Designer should produce a best design, making life of all others easy. Contractors should work in such a way that maximum level of quality should be attained with quantity. None of two, quantity or quality, should lag behind each other. Both should move together. Quality responsible personnel should encourage executives, site personnel to give their best on production more than specification compliance. Quality should teach site personnel for better approaches. Quality policing is not required, but quality contribution is needed. Prior to deliberating role of site engineer on whatever job, let us understand what definition of site engineer is. Nutshell says site engineering indicates a chain of carrying out various engineering works, descriptions belonging to all disciplines, starting from tender stage to handing over and maintenance stage of building or structure whatsoever. or on whatsoever project owned by in any sector, government or private or others. Supervision and says on supervision level, engineers are deployed in capacity of resident engineer or whatever else capacity to work on behalf of contractual engineer or real engineer who is responsible for project. Contractual engineer is meant filled in to an engineer specified or defined within legal contract documents. Contractual engineer further delegates executive supervision powers to resident engineer within the governments. To my awareness, there are 5 categories of engineers starting from chief engineer to junior engineer. This is just for information. Since chief engineer is originally responsible for all contractual decisions at head of department capacity, project should come under authority of chief engineer as contractual engineer. All further engineers down to line of delegated hierarchy should be described as resident engineers of various levels or designations. Construction and says project manager, project engineer. Downwards organization line to foreman, supervisor and charge hand work in any construction contracting company. All these designations are factually responsible for achievement of project construction execution in case project is designated as EPC, that is engineering, procurement and construction. Various sections as defined are integrated to work together with independent authorities controlled under competent coordination. An engineer who represents construction company on actual site and functionality reports to engineer's representative, resident engineer on site, is designated as site agent or site in charge or site manager. Depending upon contractual requirements, this engineer is designated as a responsible site engineer for project under EPC. Such engineer owns responsibility of all sections functionally. Virtually, resident engineer and site agent are considered equal as project site authorities for functional purposes on site organization from different parties. Resident engineer is responsible for all works of supervision carried out on project. Cost responsibilities are owned by engineer and not resident engineer. Final power still is owned by engineer for all contractual purposes. Site agent, site representative is responsible for all works of construction carried out by contractor on project. Site agent engineer posting is formally approved by engineer or resident engineer's recommendations. Approval of site agent can be withdrawn at whatever time by resident engineer on behalf of engineer. Contractor has to produce another competent site agent to replace outgoing agent. An engineer supervising engineer reports to resident engineer and work for contractual engineer. All site staff of contracting company, including subcontractors, report to site agent. The size, magnitude of project demands number of further site staff to meet requirements. Many site engineers to practically, dedicatedly supervise all works. Many be employed on various sections of projects in many constituted team under senior site engineer or construction manager. Now, various sections are organized under QA system requirements on all projects. QA system means quality assurance or quality requirement system. Now it is ISO 9001, 2015 in force, 2008 has gone, 3008 is no more. So we are talking of ISO 9001, 2018 in fact. Safety, engineering, planning, contracts, construction, surveying, quality, materials, administration, etc. are various strong model, typical sections established on generally every site. All these sections have relevant detailed roles to perform on projects. Roles are defined in project quality plans. We have to discuss site execution engineer's role in this talk. And there are, you can say, various stages we can just classify as site takeover, site planning, site mobilization, site surveying, site start or kick off, site construction, site quality, site supervision, site completion and maintenance. Earthquake management (EQM) is involved in general with site engineering site coordination. Site engineer has no definite independent direct role on earthquake management but indirect role to implement designs, engineering and project decisions to comply with quality systems with strongly extended base supports by all responsible disciplines sections on project. Site quality plan and site safety plan must describe functionally as well as reporting roles of all responsible engineers on project. Both documents are very significant to perform on content project. Since site agent, site representative is responsible in all respects for site role multiplies as follows. We can say design review is first role. Design review is first engineering activity to make sure that design specification requirements have been included within design philosophy. Engineering section performs it. Then soil report requires a thorough review through engineering section. It is to be made sure that all recommendations included by soil or geotechnical engineer have been converted within design. In case of any pinpointed observation, in case of whatever pinpointed observation, it should be brought to notice of designer through agreed procedures. Should also be specified on design drawings the specific value of soil parameters adopted on design. Certain parameters must be confirmed by testing, preferably on site prior to laying foundations. In case localized soil does not allow adopting design parameters, design should be reconsidered. It's also responsibility of site engineer to conduct this soil test in all major areas of site, employing approved laboratory if so required or contract. And site quality engineer has to involve for quality certainly of test. Whatever variation from soil report should immediately be reported to soil laboratory and designer. Resident engineer has to make sure that testing system is complied with in line to standard procedures. All relevant engineers must sign inspection and testing plan ITP for such activity. Testing of all materials according to specification requirements must be conducted to ensure that demanded quality conforming materials, particularly reinforcing bars, is an important item for purpose of procurement rightly. Concrete tile mix should also be carried out so that right quality required mix from RMC is produced to meet design requirement. Piling should be done fully in compliance to specific design and test load requirement. Load test as well as integrity test must be rightly and satisfactorily conducted. Connections between piles, cut-off, level and pile cap should be rightly satisfactorily made. Test piles activity must be conducted much in advance. Site engineer through engineering must make sure that all drawings contain right ductile detailing of reinforcement. In case of whatever detail missing, should raise immediately relevant query for confirmation. Arrangements must be indicated on typical standard drawings by designer. It's very significant for proposed materials to register EQ forces, seismic forces, which include materials should conform to standards without any adjustments. No compromise should be made in quality of these materials. Generally, it is RCC that is often included on various buildings and it is certainly considered for designs. It is significant to produce concrete works with good quality and no batch of concrete should be allowed to be poured unsupervised. Site engineer must ensure that whatever precautions are required to be taken on site should have been explained to all responsible skilled craftsmen. as well as foremen, supervisors, and charge heads. Missing information causes quality problems that leads to NCR non-conformance report. Once non-conformance report NCR is opened and issued to site, its remedial action and its closing is a must, or else payment has to be stopped for affected part of contract until NCR is closed after satisfactory remedial measures are done or applied with. All requirements should be included on relevant method statements clearly. All detailed method statements should be approved ahead of whatever activity. Generally, RCC building may require 20 to 30 standard statements, while there would be whatever number of specific activity statements. All approved statements should be followed in through letter and spirit to produce quality work. All quality control must be conducted during concrete pour. They, these may include slump tests, air voids, volumes, concrete temperature, concrete mixing, concrete finishing time, etc. Now, I have gone through various activities to be conducted, in which I said about bar building schedules and many others. Before going further, I would like to have further look on project management, and that is what actually, because we are talking of role of site engineer, and that cannot be in isolation. That role must be in project management way, and project management which is not so easy, or you can say it is not, you can say, controlled by some order. It depends from project to project how it work, but main points are already there, and that is what actually project is all about, that we have discussed before. Just a brief I will give here, means project requirement, region and brief talk, then project management concepts and necessity. And project management, it is a brief analysis to understand how to integrate project plan with required knowledge areas, and structure sequences of project management, knowledge areas requirements, risk response plan, risk management plan, communications, initiation, projects initial charter and constituents, planning and development of project plans, major processes, constituents. And within planning knowledge areas, area integration, development of plan, client client owner meeting deadlines to release bid documents, and bidder or tender meeting deadlines to submit bid, execution or implementation processes, communication channels or processes, involvement to all relevant partners, and monitoring and updates, continuous process during project life cycle, lessons learned from mistakes and incorrect decisions, completion or closing and administrative controls. Now, why this was done actually, why I have tried to improve this as reason is, we talk of real project management here. Contents well known to we, one of ourselves, have been inserted into various parts. You know these, means I cannot say that people are not aware of this, but I just try to organize it in a way that it should be on paper or on video. Now, project management applications are well known to all engineers, but presentation is an attempt to refresh reader by a brief deliberation or deliberative participation or proposition. At the end of presentation, one should feel comfortable about the precise refreshment of most aspects of project management. Presentation be revised further for future development. Well, we are talking brainstorming here, means postings are welcome. Well, project requirements, reasons, brief talk is there are so many ways, means you can just define this why project manager required, and that's only out of here, means evaluation of society and development. We say one part is evaluation of society and development. The other is marketing, demand for all operating unit organizations, and then business need of commercial houses, and customer requests for modifications and technological advances in the globe, legal requirements for implementation of laws, and then social need fulfillment, And if you go through brief of this, you may understand what I want to say is, for example, evolution of society and development stage. Movement of time obviously results in regular development of all economies. Such developments certainly require fulfill demands of facilities of infrastructure in an economies so that new products or processes may be generated. Evolution creates projects from all disciplines, and projects would be in intradisciplinary allied ones. Technological upgradation and newer technologies generate requirements of projects or services and lead to operations. The marketing demand for all operating unit organizations do require maintain their status and promote their commerce. That would certainly impose on organization to explore possibilities how to contain their markets by further adding various schemes of new products or supporting products. Business need of commercial houses maintaining maintaining and promoting existing business requires various types of strategies, and management has to bring in certain additional projects to maintain status even at cost of additional profit for a considerable length of time. Customer request for modifications. Customer is ultimate client for whatever organization. Customer satisfaction is utmost important goal which whatever organization has to achieve. Customer requirements or new demands are required to be met in a given length of time. Customer has to be provided additional value for product or service being provided at same price or in a competitive environment at curtailed price. Such requirement has to force provided for additional standards or schemes that result in delivering entire products in addition to original product or to provide improved products. New projects are required to be thought of thought of to keep hold on customers. Then technological advancement in globe, well known well known to all that technology in all disciplines keep on changing with a fast pace that forces industrial business groups to maintain update on technologies so that existing products are adopted to newer uses that shall definitely result in better quality product with lesser cost. Particularly in electronic world, technologies change very fast that demands for revision on all products, resulting in generation of additional projects. Legal requirements for implementation of laws, notification of newer laws, for example, environment improvement laws, etc., would require improvement on many products existing in market. International laws would also necessitate similar actions on, on industries. Various local laws shall force area relevant to bodies for launching newer projects. Social need fulfillment. Social society keeps on changing continuously as defined in social change, but in parallel, society keeps on adopting newer lifestyle that requires newer products that results in newer projects. All other society shall never be constant in living and adopting standards, while projects shall be kept on requiring in economies. Now, part 2, it is project management concept and its necessity. Just to share about professional experience with you guys, I'm pleased to initiate this series of actual project management requirements that need understanding and attention by general specialist engineers. Project management subject has been ignored by many budding as well as practicing engineers in light of misconception that it's separate discipline. Professional engineering spectrum require a good understanding about degree of attainability of engineering management in whatever branch of engineering. Subdisciplines of engineering designs projects are well required to be duly integrated with whole spectrum of project management. decisions and implementation processes, without which role of analysis and design engineering go futile to major extent. Those who do miss management principles and their interaction followed by implementation as well as monitoring find it almost difficult to sail smoothly in turbulent state waves. Many publications have been issued by various specialist institutions such as PMP based on general understanding about general management of projects. While those publications are not customized to real civil engineering projects as evident by excessive explanations and formatting designs of processes that makes subject entirely cumbersome and understanding approach. It's important to know that about all aspects of project management rather than trying to dip into voluminous books that allow no schedule out of busy schedule of every practicing and professional engineer. It's also true that various sequences about inputs as well as outputs on various processes and knowledge areas do not comply with requirement of try to mislead engineers. Now, an attempt has been made. I made an attempt to bring a few sheets of papers, major requirements that would certainly be meant for whatever all projects during all phases of project life cycle. Practical experience has been put on papers for budding engineers to learn about virtual management not available in single chapter elsewhere. It has to be noted that value of management of projects depends on an individual knowledge, commitment and dedication for project, spirit of management and proficiency of leadership, power attainment are required to operate all stages of whatever project from free feed to chasing out. Now, next one is project management. What actually is project management? We are talking of. That's important because once we understand project management, we can define role of site engineer or engineers. You can say project management. What actually it is? Project delivers objective. Our objective is that we have to deliver project duly constructed. That's our objective. All deliverables, not leaving a single one. That is our objective. So I have to ask myself, what do I understand by profession of project management discipline? What do I understand? That's a definite point that we have to finalize. What I say, it's not mean it's mere definition. It should be understood properly. What I written is applications of our knowledge. Whatever we have learned in field is called our knowledge. Applications of our knowledge enriched with advanced skills, means every day we learn some technology something and something. So you may say advanced learning is enriched your our knowledge whichever you have, it's enriched with advanced skills. It enriched the skills as well as organizational environmental factors and processes, tools and techniques to deliver specific results or services to client or customer in line with project delivery plan. Project delivery, all deliverables, requirements through route of project management plan. Means we have a management plan, we have to devise certain plan. So I saying change controls, project management plan, project execution and project change controls. Using, you may say, leading and organizing potentials. We have certain potentials. We have to use this potential. This is using leads and organization potentials, all integrated. Now, what are integrated factors? Here, whenever we have a project, we say this is the scope of project, what we have to do. That's called scope. Then we say what sort of quality we have to produce and what time we have. Yes, we have a scope, we have to do this. What quality standards we have to adopt, what time we have, and how much cost we have to spend. And when we do all this, what factors are giving us risk? What factors shall put us in danger? That's called risk. We have to discover those risks and then apply their corrections. And then what sort of human resources do we need? What sorts of materials do we need? This means human resources and procurement, and how we have to deal with people, with other all everybody, all stakeholders. That's called communication plan. These are major. There may be many more. So we have number one scope, number two quality, number three time, and number four cost, and number five risk, and then number six human resources, then number eight procurement, then number eight communication plans, and can be more, but these are main. And out of these, quality, time, and cost are of prime importance, because these cannot change on their own. You have no right to change costs as an engineer. You have no right to change time allotted to project, and you have no right to substandardize quality. These are main. And scope, if changes, time can change or may not change. When scope changes, construction cost can change. Or when we have to see risks, means what risks are there? If quality is not achieved, if time is not achieved, and if cost is not maintained, what risk factors are there? If safety is not achieved, what factors are there? And then human resources, how it impacts us, how many people we have to bring, how we have to manage our time according to schedule, and material procurement, and vendors procurement, and communication plans. These are main factors that dictate project. Then brief analysis to understand how to integrate project plan with required knowledge areas. These are all knowledge areas. We have whatever factors we have discussed and whatever else would be they use. These all are based on knowledge you have or you should have. Construction projects spectrum relevant to civil engineering specialty disciplines required in field. Now what they are. Project management is defined briefly as an exercise of doing total prospective processes applicable for years to deliver agreed objectives to end user, consumer or client or owner of project. Exercise of doing total prospective process, then project is defined as a temporary plan or scheme for a generally from permanent existence of some or whatever specific objective for a certain and specific purpose or service. Duration of project could vary between months to years and also to decades as well, depending on magnitude of project. Projects can belong to all classes of engineering specialties that may affect nation building as well as to meet international requirements. Project management is a broad term used to define project from its inception to deliveries stage and maintenance thereafter. After project is delivered, term changes to operation that could be a part of maintenance or consumer deliveries or to render regulate public service. Project and products are different. Terms applied to different status. Project as defined as a temporary execution, while product is a regular manufacturing process requiring operational arrangements. Continuation or future of products depends upon competitive market, economy, and products sustainability by adopting further developments. But project is entirely entirely independent of such factor, but to evolve fully supporting system for delivery of requirement so that it can be used as a permanent objective successfully to be used as production infrastructure mechanism. There are certain projects of all types in market or industries or organizations in which discussion in addition to talk about projects dealt with in civil engineering industries, and these could be, you can say, client or government or private owner or ministries or international organizations, security related projects, local self-governing bodies, statutory companies, government companies, public-private partnership, non-government organizations, petrochemical industries, heavy industries, industries of all sorts, real estates, housing of all sorts, commercial, institutional, contracting company, private companies or entities, private promoters, private individuals, and so on and so forth. So, what type of projects are manageable then? You can say government as a client and awarding to contractor, government as a promoter executing self through departments, organizations executing self either for promotion or to meet market demands or to make updates. Organizations working as contractors for all classes and all disciplines. Now, studies required for a project are entirely different. Evaluation of whatever project starts with economy, requirement, and understanding of viability in future. Feasibility study tells whether feasibility study tells whether or not proposal can be adopted depending on location, availability, or meeting development demands. Feasibility studies take its own time, and after successful completion of studies and consequential declaration of project or scheme, demand or suggestions, budget has to be arranged by client or whosoever would be owner of project. Funding is required based on this study as budgetary, so that further follow-up process is in gross scale can be commenced with. Without provision of budget data and certainty, project cannot move further. FEED, that is front-end engineering design, documents, prohibit publication, defining thorough requirements of project designs, technicalities involved, and required specifications from designer as well as from contractor. Stage is too technical and requires usual personnel with specialty potential. Hundreds decisions are requires policy of project. Now, designing a project with schematic details for development documents, followed up by further documents. This stage is subsidiary one to feed that requires in-depth technical detailing for purpose of top liner execution on front. Hundreds of decisions are required as implementation and to cost effective scopes. Now, project deliveries can be made based on thorough study, decisions, making, implementation, monitoring, corrections, updating, reviews, provisions of additional budgets, absorbing or mitigating possible risks involved with whole procedure or project stages. According to management structures, specific terms are used to draw supports to manage projects successfully in a professional way, though these are not least but exclusively referred to a guiding principle for whatever professional interested to understand what management is all about on any or small or considerable size project. Project management includes application of understood knowledge areas founded on certain technical processes in tools and techniques, forms for planned successful execution of all project activities as defined below. Certain knowledge areas within management structures are as follows. At its project stages include, let us see this one. Was I talking about in role of site engineer? Now we are actually moving into a sphere where real roles are defined, where you have to incorporate yourself with or you have to keep away. You have to decide that one, and that is actually very important study which we are going to make it now, and that is very important one from viewpoint of professionals, site engineers. As I discussed just before that, our role is not limited to scene activities but must cover scene activities and hidden activities which are concealed one from viewpoint of public. I just talked brief about project management, and this project management is not very descriptive one, just brief idea I have given. You know it already. I just said what are basic criteria that should be considered for new project or for ongoing project. All are covered in that because we are talking of engineer's role on these management issues or project construction issues or where we should understand our role, where we have to do, because there shall be no one to tell you what is your role. If some organization is there that is professional and that company gives you a job with described role, that is also minimum. That is no hard and fast line, you cannot go beyond that. You have to think about that's minimum one. Means this you can say is an eligible criteria for you to qualify for that one post or position. That's only for that purpose, not for something else. Now we have to see what is that something else. We have to consider how can it be brought to papers, means what our roles are. For that we have to understand management, not that management of administration. It's not management of company, it's management of engineering activities, you can say that way. Engineering activities management. And where do I fit in? Where do somebody else fit in? Everybody has to fit somewhere else. So what is actually, let's just think of that before going further. Yes, we should go further like this. Now what is project stages include, you can say. We can say initiation, right? You have to initiate something. Initiation, then planning, then execution or implementation. Initiation, planning, execution or implementation, monitoring and updates, completion or closing out, followed by maintenance and operation. These are prime stages. There are so many stages among these stages which we are going to talk. Now, structure sequences of project management knowledge, knowledge, that is, you can say, are areas requirement. What knowledge areas are given? Let us say scope charter. What is charter? Scope charter. Decision making stays about project. Charter authorization. And what is that? This is what you have to understand to define our role of engineers. I think you understand what I mean. Role of engineer we are defining. This is not formalized role. This is a role that we can take up ourselves. Means as engineers, we are required to understand our respective role in whatever capacity we are. We may say scope charter, and that is called decision making stage about project. Charter authorization. Can say, let us say we start with feed front end engineering design. Let's then Describe your deliverables. You have to write what deliverables are. So that's called description of deliverables. And then contract requirement. What does contract demand of ourselves? Contract requirements. Contract sufficiency. That is very important. Whatever are given, whatever documents we have, do these documents talk of contract sufficiency? You may be given some job, but job is not clear to you. That's what I'm talking of. It's called contract requirements, contract sufficiency. Your contract document should be sufficient to let you do the job without causing interference from others except for purpose of inspection. Then specific duration. Specific duration means we know that. What is specific duration? You can say time. You can say specifications, of course. Means what you have to do. Then charter. What are risks involved in that? Then who are stakeholders? Who are shareholders? Who are sponsors? Who are financiers? Who are contractors? And who are clients? Who are consumers? And organization partners? And subcontractors? And possible investment? Possible returns? Possible reputation enhancement? Prestigious or ordinary project, other projects in hands. Capacity of organizations, expansion of organization, maybe project discarded currently. Project manager and all other depending on type of considerable project. Resources allocation, charter authorization, etc. Once again read, and it says, it's not so boring anyway. What it says, let us say field, front-end engineering designs, description of deliverables, contracts requirement, contract sufficiency, specifications, durations, charters, risk involved stakeholders. Risk is involved stakeholders, shareholders, sponsor, financer, contractor, clients, consumers, organization partners, subcontractors, possible investments, possible returns, possible reputation, enhancement, prestigious or ordinary project, other projects in hands, capacity of organizations, expansion of organization, maybe project discarded currently, proper manager, and all other depending on type of constable projects, resonance, resources allocation, charter authorization. Then we will go to part of quality. This is part of project means like I can say it is part of overall activity. Cool. Now type of quality standard to be achieved on deliveries. Quality standards to be achieved on deliveries. Total quality assurance or management, right? Total quality. Quality requirements or quality plans, that we have very important subject here, quality plans. Then quality procedures, quality performance or performance quality, or say quality or value of financing, quality of procedures, quality of competitiveness, quality returns on investment, standards of quality, quality implementations, degree of achievable quality on project, optimum quality for optimum profits, quality quality possibility for all sections relevant to project, value to be achieved after project is delivered, quality meeting or exceeding customer or end users expectations, value to be provided by project deliverables and to client or owner. There is a time means time, what time says significant factor which governs project stages. A little lazy, no problem. Significantly, most valuable factor that may govern acceptance of a project is time. Time. Time waits for none. Simple. Time waits for none, remember. And remember, time is value. Time is money. Time is power. Time is hope. Time takes you to destiny. Time is friend with none. Time must be utilized. And if you don't, it doesn't come back. Take it this way. Time means significantly most valuable factor that may govern acceptance of project is time. That may not be allowed in excess of agreed, keeping in view competition as well as additional cost that additional time may require. Time not allowed to vary. Time allowed to space for valid reasons. Time schedule acceptability. Effect of time schedule by force majeure. Effect on contracts. By standard provisions such as FIDIC or non-FIDIC agreements. Non-FIDIC agreements. Effect on long lead items, effect on importable items, vice versa, effect by such items on project schedule. Time recoveries, methods, critical activities, stages, crushing time, schedule, fast tracking. Costs affecting all parties involved on project. Do you know what it's been? Five minutes. Let me start from time if I can do this. I want to see if it works or not. If it works fine. A little feeling with drowsy. That would remove my drowsiness. It is crazy weather. Let's see what works. It works fine. It will work okay. Some suffocation. So cost affecting all parties involved on project. Cost on proposed project, maintainable cost for project, maintainable variations, provisional cost, equipment cost, construction cost, resources cost, prime cost, cost in long run, annual expenditure, budget expenditure, budget provisions, loss of cost or profits should project be shelved. These are various questions related to cost. Because cost is of utmost importance, and if there is no cost, you cannot do project. Means budget. So what it says? Cost on proposed project, maintainable cost for project, both are there. Construction cost and maintainable cost. Then maintainable variations. Then provisional cost, and then equipment cost, and construction cost, and resources cost, and prime cost, and cost in long run, annual expenditure, and budget expenditure, and budget provisions, and loss of cost of profits. It should project. We shall is a question. Risk factors. Limit if there is no cost decision. Project cannot move simple. So simple. Risk factors. What are risk factors? Which can affect everything. Scope, quality, time and cost. We say quality, time and cost are there. Scope is included with that. Scope, quality, time and cost do affect project by impact of certain risks. And all such risks should be anticipated in advance for reaching and applying preventive actions or solutions. In case preventive actionable solutions are not available, 100% risk responsive methods or plans should be produced after having understood details posed by indicated or considered critical risks. Certain risks may be considered as indicated thereafter. What are those risks? Risk impact due to change in scope. Suppose there is change in scope. Addition or deletion exceeding agreed percentage levels certainly impacts risk on project. When project charter has not been prepared based on complete understanding of project, implications that are generally defined within body of project control clauses and project specification documents, and when deliverables have not been correctly listed, project is generally impacted upon when it belongs to lump sum category, contract category. It's adversely affected budget cost. It adversely affects budget cost, contract time and performance quality. So this is one risk impact. You say, then there is a risk impact due to change in quality standards. Quality on works, if enhanced or produced substandard, impacts considerable risks. Substandard quality results in rework, while super quality than agreed results in both time loss as well as cost loss. Moreover, quality requirements must have been explicitly understood at scope formation phase and must be clearly documented within charters. Applicable codes, standards and market practices must be correctly documented for consideration and guidance. Procurement based on substandard quality shall not serve whatever purpose, shall not serve any purpose whatever but jeopardize project performance. After being rejected and contribute to requirement of additional time or additional expenditure or cost and time overruns. Detailed quality management plan is a requirement on every project. So, risk impacts due to change in schedule time. This I discussed was risk impact due to change in quality standard, and then the risk impacts due to changes in schedule time. Schedule time, or use it time plan or time frame, whatever you can call it, doesn't make a difference to me, but it is schedule. Lost time impacts, we lose time. Lost time impacts project budget by cost of additional resources. Mobilization in terms of human workforce as well as machines or equipment for both. If time is lost, you have to pay for additional services. Recoveries to delayed schedules are sometimes impossible. Impossible that makes extension of time certain under compelling circumstances. Delayed decisions on engineering grounds, procurement grounds, or non-availability of required skills do result in delayed execution of relevant activities. In case scheduled time is lost due to whatever reason, balance of works shall have to be executed in defined scheduled time by either mobilization of additional resources or by working overtimes and on holidays as well. For tracking system, tracking maybe scope. Okay. Now, for tracking maybe fast tracking may be required to many sequential activities on schedule. On schedule maybe crashed. In case this recovery method is not feasible, schedule time shall overrun and add a cost. In case this recovery method is not feasible, scheduled time shall overrun and add cost to project budget in form of liquidated damages as well as further extra expenses on budget provisions due to additional resources engagement. So what did it say then? Risk impact due to changes in cost. What we discussed was changes in time, and before we discussed change of quality, and before we discussed change due to scope. Change due to scope, we discussed change due to quality, we discussed, and change due to schedule time, we discussed, and now change in cost. Change in cost. Cost changes due to reasons, whatever, certainly add to project's budget. And project budget cost generally addition of escalated cost, and in the remote areas there could be savings by change request. Time change adds to cost. Material delay adds to cost. Quality impact adds to cost. Scope addition in case against rates add to cost. Quality impact Quality impact adds to cost scope addition in case against rates. Hmm? Cost changes due to whatever reasons would certainly add to project budget cost, generally addition of escalated cost. In remote case, there could be savings by a change request. Time change adds to cost. Material delay adds to cost. Quality impacts adds to cost. Scope addition in case against rates adds to cost. And some cases import losses to total cost even by addition of many works onto original scope, while in some cases omission or deletion of considerable scope items result in time or cost saving. Risk impacts due to partly unknown scope. Risk impact due to partly unknown scope. Major factors that can jeopardize a certain portion of project performance in its entirety when demanded scope is not clear to executor or contractor due to whatever valid reason or explanation given by client. It affects badly on performance. Risk risk impact due to partly unknown scope cost. Well, a major factor that can jeopardize certain projects of project specific performance in its entirety when demand scope is not clear. Okay. When demanded scope is not clear to executor due to whatever valid reason or explanation given by client, it affects badly on performance of project and definitely not a desired acceptable condition. Unclear scope, definition, or hidden provisions may lead to a dispute in many cases, which would land both parties either to arbitration or to court of law. Okay. Now, risk management plan. We'll take up them separately. Now, let me go back to role of site engineer because that is what our aim is, and that's actually very significant one. We are talking for support of those engineers who are really interested in this. We have talked so far, means what we should do on sites. We said all steel bars, let us say, we have already said, but again I repeat, all steel bars details must be produced in form of bar bending schedule prior to giving fabrication. They should meet requirements to avoid stresses, localization, As far as practicable, overlaps should be avoided. Rings or stirrups should be fixed in such a way that hooks do not continue on one side, one end. Let's say should be should be remember that reinforcing bars during earthquake action time charge change behavior drastically. How it happens? Bars provided with gravity loads start accepting horizontal shear distributed stresses, thereby forcing beams to work as columns and columns to work as beams. That makes an essential as requirement to gravity to tightly blind all bars and to no bar should be displaced during tightly blinds or uh, so we remember that reinforcing bars during the quick action time change behavior drastically. Bars provided with gravity loads start accepting horizontal shear distributed stresses, thereby forcing beams to work as columns and columns to work as beams. That makes an essential requirement to tightly blind all bars. And no bar should be displaced during concrete pour or during vibrator application. All bars should behave in continuity. Vibrator must not be allowed to touch any rebar or formwork surface any time. No over vibration should be allowed. No pulling or pushing of concrete using vibrator needle should be allowed. No segregation should be allowed. No segregation. After that goes okay, fine. Vibrator must not be allowed to touch any rebar and formwork any time. No vibration should be allowed. No pulling or pushing of concrete using vibrator should be allowed. No segregation should be allowed. All concrete must be vibrated properly. In case of voids formation, thorough investigation should be conducted and then remedial actions resorted to. Then I'm going to read all this for you, then we'll talk of what you want to say. Proper inclusion of concrete spaces, also called concrete covers, should be made at right locations so that rebars keep intact during pouring activity. It is generally been noticed this item is neglected by site engineers as well as other persons. Then cover is too serious an issue to be considered as a precast covers well cured can be used. Plastic covers, if strong enough to bear loads of foundation rebars, can also be used, but below heavy reinforcement assembly plastic spaces have been experienced unsuccessful, though not discouraged. If is strong enough to sustain the required strength during preparation as well as during concrete pouring. Formwork. Formwork should be erected based on correct and safe design of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented, particularly large suspended slabs forms supporting systems. Scaffolds must be certified by third-party scaffolding system specialist before concrete is allowed to be poured. Systems should be erected in conformance to design received from specialists based on moments, shear force, etc. Uh, uh, Sorry. Well, in addition to usual quality control tests, such as slump or cubes, compressive strength, additional tests should be considered for cores drilled or to be taken out from various locations to make sure that site conditions match laboratory conditions for cube test purpose. Curing is responsible for life of concrete and therefore must be given due care and control and the direct command of a responsible person. No leniency or worry about cost of water or curing compound or Hessian or polythene sheet has to be taken care of. Then let's say any defects observed after striking forms should be reported to site engineer and through whom it shall reach resident engineer. Right? Any defects observed after striking forms should be reported to site engineer and objector. Then no horizontal planes of weakness. Well, I said that before that observed after striking form, no defects. Any defects observed after striking forms or removing forms should be reported to site engineer and through site engineer and after inspections to whom the resident for remedial actions proportions. No horizontal planes of weaknesses. Yeah, we understand that as engineers, everybody cannot understand that. It's no, no city. Yeah. It's only for cities who think no, it's for a site, which area it is there. So don't shy. So actually, I am always wrong. Right? No horizontal planes of weaknesses, I should say, should be preferred. As far as practicable, concrete pouring should be planned for monolithic concrete action. Construction joint should be agreed in advance for an easy execution purpose. In case construction joint in emergency in a construction joint in case a construction joint is in emergency required to encounter failure of plant, location should be decided with agreement with resident engineer. Wherever required, the soil improvement has to be carried out to achieve required required safe bearing capacity. SPC imported desert fill or graded fill has to be used for purpose of limiting liquid limit as well as plasticity index. What is liquid limit, that you have to understand? Common definition. There's a dry soil. It is certain strength, say shear strength. You go on adding water to this. A stage will come where strength of original liquid will be down than what you did before. This means you are learning this statement. You are learning this. You think so? It's not learning one. This happens repeatedly. So what I say, when you go on adding water to soil, dry soil, at one point of time, soil starts losing its shear strength or its content of phosphorus. Remember that. Then what is liquid limit in this case? Means when your soil starts losing its shear strength, that stage you can say it is liquid limit. Generally 35%, 40% is accepted in hard soils and very little in higher soils like crushed. Well, liquid limit as well as plasticity index to a minimum value. Internationally, liquid limit is restricted to 35%, while plasticity index less than 6. Soil improvement shall be required for areas where soft or weak soils exist. These weak soils are required to be removed and then placed with good granular materials. ये पका नहीं था ये आई की नहीं हो. Whatever required soil improvement has to be carried out to achieve required safe bearing capacity. Imported doesn't fill, as I just said, we can use that. Soil improvement shall be required for areas where soft or weak soil exists. These weak soils are required to be removed and then placed with good granular materials in layers. They have decided they want any time. Well, these weak soils are required to be removed and then placed with good granular materials. Line down lines is only this, nothing else. So we can say these weak soils are required to be removed and then placed with good granular materials in layers during compacted to achieve specified field density. Backfill. Backfill is one activity that makes a lot of difference on future of foundations. It must be rightly conducted, carried out. It has been observed that site engineers try to neglect supervision and save project time by filling thicker layers. It's not a good one. It's not good practice. Backfills should be not less than backfill is one activity that makes a lot of difference on future of foundations. Must be rightly conducted and understood. It has been observed that site engineers try to neglect its supervision and save time. Uh, it must be rightly conducted. It has been observed that site engineers try to neglect its supervision and save project time by filling thicker layers. It's not a good practice because the backfills should be constructed in good layers. Researchers who has taken that? Yeah. So in backfill should be in good compliance to accurate specifications. Uh, Backfill should be in good compliance to agreed specifications respecting engineer or structure fill to achieve 95 to 98% dry density and as it do it again. Construction sequence, whereas a 95 to 98% in structural fill, whereas in general fill it can be up to 90%. Engineered fill is 95 to 8%, right? Uh, well, no problem. Construction sequence, we have to see construction sequence. What is the foundation should be planned as far as possible to be cast monolithic, but it usually doesn't happen because of so many reasons. But let us read it now and we will discuss later. What should be done, what should not be done. Foundation should be planned as far as possible to be cast monolithic. Column should be cast first. Beams and slabs should be cast one time monolithic. All connections should be done to meet requirements. It has to be ensured that proper bands are used in brick or stone buildings that have been required for EE resistance. Long walls should be inserted with bonding columns and bonding beams as required by specifications. So we just said before that it has to be ensured that proper bands are used in brick or stone buildings that have been required for accurate resistance. That after long wall infill walls. Infill walls should be taken up for later after completing framework. Alright, then we say long walls should be inserted with bonding columns and bonding beams as required by specifications. Infill walls should be taken up for later after completing framework. Then can say connections between columns and walls should be made with proper fastenings. Factually speaking, all constructions activities must be complied with design as well as specifications. Requirements. No negligence should be allowed. You can say QA engineers have to similarly involve to check and inspect all activities by observation in addition to signing ITPs. Resident engineers should keep an eagle eye on activities. Contractual engineer got full right to reject whatever activity proposed. Resident engineer should keep an eagle eye on activities. Contractual engineer got full right to reject whatever activity approved by resident engineer. Basically, responsibility is shared by site agent in an overall perspective. Quality product should be a must requirement. Keep in mind, services too can break, during earthquake action, services can break up. Right? During the quality part should be a must requirement. During earthquake, services too can break due to horizontal forces, which require strong and durable fills around with durable joints. If we can, uh, and move further. All elements of buildings as well as finishing should be well secured and durable so that during earthquake impact these are not distressed, associated with or torn out. Now points of attention. We'll discuss all these in details. Let us now finish on to read this for information because these boys and girls are expected to go out for this. Points for attention now. Let us see what time is left. 1 hour 47. Now we have time, no problem for that. Site engineer should not decide by itself about any engineering design on cause mistakes for whatever reason whatsoever. Many aberrations from quality compliance and their suggested solutions are noted as follows that should be taken care of. Now say that rusted and bent bars rusted or corroded and bent rebars are delivered to site or to fabrication yard. Straight lengths without rust only should be caused, should be used as well. Alright, I'm going very slow because there are technical points you must remember. If I go very fast, you will miss this. Rusted and bars, bent bars are delivered to site or to fabrication yard. Straight length without rust only should be used for fabrication after ascertaining laboratory tests. Let me sit a little comfortably. Stretch my legs, of course. Okay. Rebars are placed on ground Rebars are placed on ground soil and not on good wooden or other base supports without even covering with polythene sheets. Precaution should be resorted to for good handling and storage to keep stock out of moisture contact. Sorry. Rebar dowels may be forgotten to place at various joints connections. Chemical anchors should be used for inserting forgotten dowels. Do not chip hardened concrete and insert small hook. Drilling shall be required to comply with chemical anchors. Manufacturer's recommendations must be must be complied with. Inserts and embedments of services at various locations may be missed. Approved shop drawing should be used for inserts locations, coordinate inserts locations at structural details. Block outs for various building services may be missed. Approved shop drawing should be used to overcome such problem. Coordinate these locations to structural details. Sometimes due to site negligence, sometimes due to site negligence, certain concrete elements may be missed by overlooking. Structural drawings should be deeply coordinated. Once again, sometimes due to site negligence, certain concrete elements may be missed by overlooking. Structural drawings should be deeply coordinated with architectural drawings. Generally, facets dowels are forgotten. Many lintels too are overlooked. Opening or bulging of forms at one third of height from pouring base is a common occurrence. Locations requires strong resultant supports. It should be taken care of while considering concreting plan. Chipping should be avoided if feasible by providing strong supports. Honeycombing or surface Honeycombing on surface is a common occurrence. Vibrators should be applied within seconds, maximum 1 minute. We say honeycombing on surface is a general and common occurrence. Vibrator should be applied rightly, produce a smooth and nice concrete surface, truly straight and vertical without opening out. Then I say concrete temperatures are not ensured in field which range from 5 to 32 degrees Celsius only, which concrete is poured in temperature of 35 to 42 degrees Celsius. Say concrete temperatures are not ensured. We have to ensure them 5 to 32 degrees, and concrete poured in temperature about 35 to 42 degrees Celsius during high temperatures. As such, ice needs to be added if mercury is around 32 degrees Celsius. Thick elements or massive blocks should be poured in 34 degrees Celsius concrete temperature. We'll see why we'll discuss. Voids formation in concrete is common occurrence. Void area should be chipped out. Void area should be chipped out to reach hard concrete surface, followed by application of remedial treatment. Use use recommended chemicals for bigger voids. Letterbox formwork can be used. To pour new concrete, to pour new concrete to old one by applying bonding agent or slurry. Exposition of rebars on concrete surface is very common. Mortar is pasted on those areas to hide exposed rebars. Concrete spacers should be placed at over all over to meet requirements. Ordinary mortar pasting is not acceptable. Chip loose concrete from affected portion and apply proprietary chemical such as epoxy based repair materials. Congestion of steel is generally seen, not anticipated either by site engineer or by design engineer. Should be discussed with design engineer. If not workable, or if workable, better arrangement should be worked out and approved. It's one of many constructability issues. Rebars are often displaced by electrical conduits fixers and by rebar fixers themselves or others during conduit inserts fixing. Steel fixers should replace affected rebars parallel to conduits installation. For higher size bars, overlaps do not work perfectly. Mechanical connectors or couplers should be used. Generally, rebars dia 20 mm and above work better than when mechanically connected. Hardened concrete Hardened concrete is as bad practice cut for passing any small air conditioning duct already missed. No hardened concrete should be cut without proper investigation by design engineer or resident engineer. Access to slum is not reported truly. No information should be concealed, but slump value should be tried to be brought down by keeping truck mixer rotating for a couple of hours. Okay. Excessive slump is not reported. I said no information should be concealed, but slump value should be tried to be brought down by keeping truck mixer rotating. Hmm. Well, hmm. In case it doesn't work, means what I said, no information should be concealed, but slump value should be tried to be brought down by keeping truck mixer rotating for a couple of minutes. It doesn't work out, mixer should be rejected. During concreting ore operations, during concrete pour operations, due to certain delay, without delay, additional water is secretly or without permission added. No additional cube sample is taken for added water bridge. If it's allowed, special cubes should be collected for that, for strength confirmation test, that is compressive test, universal machine compressive test. Record must record of ready-mix concrete details such as loading time, site arrival time, site delivery time. Okay. So, what I said, record ready-mix concrete details such as loading time. Hmm? What you have to record? No additional cube sample is taken. That's okay, we have taken that one. And record ready-mix concrete details such as loading time, site arrival time. Loading time means loading at mixer. Then site arrival time of transit mixer. Then delivery starting and delivery completed, etc. Records of element location with sufficient. Right. Come on to construction joint stop end. Construction joint stop end formwork is not readily available, keeping any emergency in view. Stop ends should be made readily available if required. It's fixed as an emergency exercise when concrete stops due to whatever reason. Construction joint is not correctly fixed. Location should either be indicated on drawing or should be agreed with resident engineer prior to commencement of pour. Construction joint is not correctly hacked or scabbled before laying new concrete on that. Do not move too fast but chip out joint surface to expose arrangement, expose aggregates by with do not move too fast but chip out joint surface to expose aggregates by removing latents, cleaning, wetting, and then proceed for laying concrete for new work. Okay. Standby vibrator is not available. It's very important to have additional vibrator to meet working requirement whenever any of the vibrator fails. Vibrators should be checked for working before commencing work. Curing is not started in time. Curing is not continued as required. Hot weather requires immediate curing, particularly on exposed or unformed surfaces. It can even be done by spraying curing compound. Polythene sheet can also be spread on concrete surface. Curing should be effectively carried out due to defined duration by personal attention of site engineer. Then you can say polythene sheet can also be spread on concrete surface. Curing should be effectively carried out to defined duration of 20 to 24. Yeah. Okay, let's go to curing should be effectively carried out in defined duration by personal attention of site engineer. Then curing is not completed for required period. Do not ignore curing. Ignorance of concrete curing can cause a major problem, and non-conformance report NCR on this account may have no solution for closing its validity of action. It's too easy to pour concrete but extremely expensive to dismantle and rebuild. Incorrect incorrect cut rebars are forced to be placed in and unusually bent further. Prepare good BBS, that is bar bending schedule, prior to starting cutting and bending. BBS can be produced on Excel sheet during using required formula. Cutting lengths should be shown in shape or bars. Stirrups are not rightly centered. Do not do not proper do proper fixing work. Proper work of rebars shall help satisfactory. Okay. Stuffs are not rightly centered. Do proper fixing work. Be proper work of rebars shall have shall have satisfactory concrete pour. Rebars are not centered properly. Do proper fixing work. Proper work of rebars shall help satisfactory concrete pour. Rebars supporting chairs are not rightly cut and fixed. Check before fabrication all required dimensions. Do not depend on steel fixers overconfidently. Rebars fixing is a complex activity. Make sure that is to carry out directly. And say rebars are not well secured. Before this, I said that rebar supporting chairs not rightly cut and facts check before fabrication. All requirements fabrication. mm, all required dimensions do not depend on steel fixers overconfidently. Reverse fixing is a complex activity. Make sure that it is carried out correctly. Mm. Make sure this is carried out correctly. Rebars are not well secured. Bind bars properly without worrying about binding wire cost. Check fixing arrangements over all joints. Check continuity of reinforcement if feasible by using voltage or current flow method. What I am saying is check continuity of rebars reinforcement if feasible. Continuity means you have to ensure current flow by using voltage or current flow method, usually employed for checking cathodic protection. That is, cathodic protection means where you have central control system of corrosion control, which is very much important on plants, facilities plants, on onshore projects, where you are extracting something and then or extracting something else also you are spending money. Then I am saying cathodic protection, which is very important term for you guys to know what's cathodic protection. This is for you can say this of course this is also there. These reports, what are the uses you can say means we have building works as well as plant building works. Plant works have cathodic protection in general, but building works don't have, because there is central control system on plants where anodic you have to fix anodes on locations, and cathodic protection is controlled from some common point. Then tie bolts are not tightened properly, you can say. Tie bolts are not tightened properly. Use correct dimensions of tie bolts and fix properly as required. Fabrication of these bolts must be done exactly to requirements. Plumb of verticality of formwork or plumb of formwork is not inspected to standards. It's a difficult exercise to inspect dimensions, locations and verticality, but should be conducted particularly for our survey. Sometimes it's like as if animals here. Well, extra provisions led, you can say, yes, plumb verticality of formwork is not inspected to standards. It's a difficult exercise to inspect dimensions, locations and verticality, but should be conducted particularly. Yes. Right. So what I said, plumb of homework is not inspected to standards. It's difficult exercise to inspect dimensions, locations and verticality, but should be conducted particularly for elements to bear equipment or where facets is involved. Extra previous laid concrete is not chipped out. Site should be kept tidy in all respects. Chip all surplus required concrete. Chip all surplus concrete. Produce good and effective construction joint. Chip all surplus required surplus concrete. Holes are not left for cleaning out dust from forms. It is practically required to dust out preparatory works. Use compressors to clean out preparatory works. If it's required to clean many times, do it. Don't do it in one go, you can do everything. Will are very fast and they think railway is same. They move on railway as if you know use compressor to clean out preparatory works. Flash setting is not prevented. Flash setting is not prevented. Use water to be sprayed on forms to keep temperature low before concrete starts. When steel bar is hot and concrete is cold, combination contact generates. Flash setting of concrete, avoid it for sure, because flash setting of concrete can cause harm, and this can come from steel when steel is too hot and you pour concrete. So try to maintain temperature of surrounding concrete to minimum. It is sun in high temperature. For line of Devi is different. So camel was around 600 IVR, right? Flash setting is not prevented. So when steel bar is done cold, hot and concrete is cold, combination contact generates flash setting of concrete and it should be avoided. Cold joints are wrongly allowed. Cold joints, you must understand, cold joints are wrongly allowed. Sequence of concrete pour repetition should be made such that concrete repetition is done fast in hot conditions. Time gap should be controlled. Concrete is collected at one spot. Concrete is collected in one spot for longer than required. Do not pull up concrete at one location. It is dangerous for preparatory works and scaffoldings. Pulling concrete is not recommended in any case. Use hand shovels if you are so keen. Then concrete is collected one spot for longer than required. Do not pull off concrete at one location. It's dangerous. It's dangerous for preparatory. Congress collective response is dangerous for preparatory works, scaffolding to pull it. Pulling Congress is not recommended in any case. Use hand shovels. Workers add additional water to soften wetting mixed concrete material that is due to delayed consumption on pouring location. Do not allow such addition of water on already mixed concrete for ease of handling by workers. That is not allowed. That is bad work. Remedial actions on defects are carried by site staff without even informing site engineer. Keep an eye on foreman, supervisor and other persons responsible. It's too significant an issue. Site agent could be removed. Doing such negligence, some negligence, say, Formwork is stuck now. What is say? Formwork is stuck midway in defined time limit. Record dates in concrete register for all pores. Record all test results. Record all curing dates. Concrete blocks are shifted due to shortage of storage space from factory to site within 3 days of production. I'm talking of concrete blocks. Concrete blocks are shifted due to shortage of storage space from the factory to site within 3 days of production. Due curing is not allowed. Means curing was not done. Cure deliver blocks prior to being tested and permanently included into works. Class 1 bricks. Class 1 bricks are not procured. Class 1 bricks are not procured or even available. Procure good bricks or blocks. Avoid using weak bricks. Avoid using weak bricks. Do not include inferior bricks below ground level or in foundations. Wooden planks are used for formwork with leaking joints. Better suggested to use ply for good results. Plywood can be economically used repetitively. Decide for number of elemental sets for formwork. Repetition judiciously. Formwork is not correctly labeled. Set out formwork properly. Check all lines and labels truly. Check all feasible as well as necessary controls. Checking controls is a cumbersome activity. Grouting for structural steel bases that are designed generally RCC foundations requires a good control as it is cement based material. Similarly, grouting for under anchorage plates requires good controls. Epoxy is good for that, right? Well, so what I'm saying is epoxy grouting under base plates of vibratory equipment should be carried out complying with specified requirements. Do not go ahead for any work where doubts do exist either in specifications or in designs. Obtain clarified answer in form of site technical query before carrying out ambiguous item. It is emphasized that foregoing points which I explained should be considered in true spirit. Carrying out better work on controls shall definitely produce a good concrete work that would certainly serve for required and desired durability. Durability. Durability for whole structures or buildings. Patience pays on site. Patience pays on site. Panic harms works. Plan properly all days to day activities. Progress is required but not all quality, all quality, all safety. Uh, okay, safety is a responsibility for everybody. Plan properly all day-to-day activities. Progress is required, but not at quality cost. Safety first and quality must. Safety first and quality must. Slogan has to be. So now, site engineer has also to be involved with retrofitting activities. Let us see what are those. Before that, we will see how much time is left. That's also important. What time is left is also to be seen. Okay, I have some time. I can continue, no problem. I'm talking of seismic retrofitting, structural modifications to upgrade strength, ductility, and energy dissipating ability of seismically deficient or earthquake damaged structures with a mission to rehabilitate can be termed as retrofitting. Once again, you can know that structural modifications to upgrade strength lost, ductility, upgrade strength and ductility and energy dissipating ability of seismically deficient or earthquake damaged structures with a mission to rehabilitate can be termed as retrofitting. Seismic strengthening, process of enhancing or augmenting the strength of existing structures to make them resistant to seismic activity, ground motion. Process of enhancing or augmenting the strength of existing structures. Process of enhancing or augmenting existing strength of strength of existing structures to make them resistant to seismic activity, ground motion, or soil failure due to earthquakes from original design status with or without, including EQ forces to be used for further higher stresses to extend service life of structures can be termed as strengthening. Okay, so I say identifications. Now let me see this para again. Process of enhancing or augmenting strength of existing structures to make them resistant to seismic activity, ground motion, or soil failure due to earthquakes from original design status with or without, including earthquake forces to be used for further higher stresses to extend service life of structure can be termed as a strengthening. Identifications are identify various priority buildings such as schools, hospitals, nursing homes, police stations, fire brigade stations, multi-story buildings, water reservoirs, electrical stations, essential services buildings, as well as lifeline buildings, etc. Surveys of restorable, retrofitable buildings can be done minutely by experienced site engineers for purpose of making a report to decision makers. All details from site observations and samples collected from site can be reported to laboratories as well as to relevant authorized engineer. It requires an extensive grasp of field knowledge of state of chronic material, personal inspection, dedicatedly needed. Recording can be done by photographs, videos, by taking all measurements of locations or of deteriorating areas. Hand excavation should be effected for purpose to collect foundation samples of old concrete. Rebar samples can also be collected from known critical areas that require a good study of time of structures either from records or from survey. Engineers should have patience while working on retrofitting. Details reports should be submitted to have an understanding about health of old building or structure. Control levels at various heights should also be recorded to reflect major settlements. Definitions of major. Okay. Control levels at various levels at heights should also be recorded to reflect major settlements. Reflections of members could also be recorded if feasible. Investigate. Okay, let's move further. We shall this paragraph is important one. Control levels at various heights should also be recorded to reflect major settlements. Deflections of members could also be recorded at feasible. Investigate as many members as feasible. It shall help making a reliable understanding of both unsound building and suggest to arrive at solutions. Then record all applied real loads on buildings either by inquiring or by observing. These can be different than what have been using in designs. Then record all applied real loads on building either by inquiring or by observing. These can be different than what have been used in designs. So formulate a convenient formula for adopting new load intensities on structure for renewal of its services in future. Columns and beams are required to be studied with good concentration. Strengthening of these members shall be very difficult. Check all deformations and deteriorations. Similarly, samples and integrity of wall materials should also be recorded for making a good report. It may be proposed to add beams or extend footings in foundations for which all existing data must be collected, possibly due to long applied building loads. Safe wearing capacity of soil must have augmented due to consolidation. Which factors should be after ensuring positively may be considered advantageously. Additional columns or beams could also be required to be added to meet various requirements for equal forces and for which all necessary data should be recorded on report. More frames could also be investigated for addition into building existing frame per frame. Retrofitting could also demand provisions of composite sections into existing one. Careful study and understanding is required for all such cases. Structural steel can also be used after investigation during new analysis. Retrofitting requires great input by investigation engineer prior to making any decisions for certain structures. It may be to be rebuilt as a whole, while for others retrofitting would be economical. Whatever be basis of considerations for retrofitting would be detailed method statements giving minute sequences shall import authoritarian. So we go this way. Whatever be basis of considerations of retrofitting will be detailed method statements giving minute sequences shall import attention. Site engineer should include all such details with elaborations for making a clear understanding of proposed proposal with right. The site should include all such details with elaborations for making a clear understanding of proposal. All work should certainly impact on budgets. And if required, reporting can also be done. Reporting can be done by conducting many stages inspections. If required, supporting can be done by conducting many stages inspection that may depend on size of structure. Separate individual records are suggested to be made for a proper post inspection survey audit. Complete audit should be worked out elaborately. What levels of surveys is best suited would be dictated by size of structure, its degree of deterioration, as well as its existing soundness. Post earthquake disaster management. No one can control disasters, whether it is caused by earthquake or is caused by other calamities. Preparedness to mitigate disaster is required. Everybody should be ready to accept emergency responsibilities. Major contribution would be required from various disciplines such as indicated below: police, army, fire, brigade, civil defense, medical professionals, equipment companies, export options. Then it is aviation, helicopter, cranes, then civil engineers, NGO activities, volunteers. In being being government constituted to coordinate, control and assist nation out from clutches of disasters as well as mitigate them. So National Disaster Management Authority. There is this National Disaster Management Authority for this purpose. Its vision is zero tolerance to avoidable deaths due to earthquake. Its mission is to formulate guidelines for preparations of plans to reduce earthquake risk and minimize these impacts, losses of lives and damages to properties caused by earthquakes. Disaster, catastrophe, mishap, calamity, or grave occurrence in any area arising from natural or man-made causes or by accident or by negligence, which results in substantial losses of life or human suffering or damage and destruction of property or damages and degradation of environment, and is of such a nature or magnitude beyond 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 coping capacity of community of affected area. Then hazard means threatening beyond all a probability of occurrence of a potentially damaging phenomenon An earthquake means, you can say, hazard means a threatening event or a probability of occurrence of a potentially damaging phenomenon. An earthquake, a cyclone, storm, or hail, or a large flood within a given time period and area. High risk areas, geographical areas which fall under seismic zones 3, 4, and 5, which are vulnerable to potential impact of zones, landslides, rockfalls, or mud flows. Disaster management, a continuous and integrated process of planning, organizing, coordinating, and implementing measures which are necessary or expedient for prevention of large prevention of mm, so prevention of danger of threat to the earthquake cause disaster. So continuous integrated process of planning, organizing, coordinating, and implementing measures which are necessary or expedient for prevention of danger or threat of any equal cause disasters. Mitigation or reduction of risk of any disaster or severity or consequences, measures aimed at reducing risk, impact, or effects of a disaster or threatening designed threatening disaster situation. Capacity building, preparedness to deal with disaster, prompt response to whatever threatening disaster situation or disaster, assessing severity or magnitude of effects of disasters, evacuation, rescue and relief, and rehabilitation and reconstruction, and non-structural measures reduce or avoid possible impacts of hazards such as education, training, capacity development, public awareness, communication, etc. Preparedness means state of readiness to deal with a threatening disaster situation or disaster and effects thereof and risk. Expected number of lives lost, persons injured, damage to property, and disruption of economic activity due to particular natural phenomenon. Risk assessments, determination of nature and extent of risk by analyzing potential hazards and evaluating existing conditions of vulnerability that could pose a potential threat or harm people, property, livelihoods, and environment. Risk management, systematic process of using administrative decision, organizations, operations, skills, and capacities to implement policies, strategies, and coping capacity of our society and communities to lessen impact of hazards. Rapid visual screening (RVS), rapid visual screening, a procedure requiring visual evaluation to assess vulnerability of buildings by permitting vulnerability assessment based on walk around a building by a trained evaluator. Evaluation procedure and system is complicated or compatible with GIS based city database, and also permits use of collected building information for a variety of other planning and mitigating purpose. Specific risk, exposed expose I'm sorry expected degree of loss due to particular nature phenomenon. EQ risk can be assessed in any area: seismic retrofitting, structural modifications to upgrade strength, ductility, and energy dissipating ability of seismically deficient or earthquake damaged structures. Seismic strengthening process of enhancing strength of existing structures to make them resistant to seismic activities, good motion, or soil failure due to say earthquake. Points requiring attention are: new buildings should be properly set out to allow easy access to areas for rescue operations. Adequate access should be included by machines and equipment to enter. Equipment must cover as required by EQ situations. Buildings should be located away from main roads. Streets should be wide for easy access of vehicles and equipment. Priority lifeline and essential buildings should be in vicinity. Standby generators plants should be provided to meet supply failures. Firefighting firefighting live lines should be available during emergencies. Roads should be resistant to EQ forces. Then roads should be resistant to EQ forces, and all existing structures prone to failure should be upgraded by strengthening or retrofitting. Trained and certified engineers and other personnel should be available all over. All these personnel should be given updates and allowed drills. Engineers and architects are being trained to learn more about EK requirements. Similarly, medical professionals should be given updates on allowed drills. They are also being trained to effectively perform during EQ emergencies. All other relevant professionals and others should also be updated and allowed drills. General public should be kept well informed and and imparted education about methods to respond during EQ emergencies without panic. Engineers can do a large job very well. Owners should be educated about benefits to include EQ resistant design provisions on new structures. Engineers can very well explain to public. Similarly, engineers can demand from architects to include all EQ resistant provisions on new buildings in public sector or in private sector. Architects are also being trained to work effectively on designs to meet EQ requirements. Engineers can deliver lectures in schools and colleges about EQR methods and about role of children and public involved. Dear friends, the role of engineer, site engineer and other engineer on buildings of all types, on structures is continuing, and I am feeling happy that I am going successfully to share my experience and knowledge that I have scripted with you. This share may work to achieve some improvement on quality aspects in field. This should work well because it's not one man job here. It's job of, you can say, like team we are working with. It's not simply a job that we can ignore. There is no way that it can be ignored. If not today, we have to learn in tomorrow time. So better learn today, and it is better as soon as we learn it and implement quality control criteria, safety control criteria and professional work criteria. Building that we deliver, structure that we deliver should be professional one. Just like I say I am professional, you say you are professional. We are professional only when we deliver professional activity. If we are not able to deliver professional activity, we have no right to call that we are professional, because we are converting natural resources to physical resources. We are converting natural energies natural materials to social change. We cannot say that it is only what we have been taught of. Yes, we have been taught in universities something, we have been taught in institutions something, but that must be physically professional now. It should be professional, and we have to take that into consideration. That is sole purpose of my talk, which is going to be continued in future as well, because it is sequential activity. हाँ जी,
हाँ जी
हाँ
भाई
जी
राम
डॉक्टर साहब,
राम।
हाँ जी उठ गए आप?
साई राम बाबा।
हाँ, क्या बात है?
भैया तो वो बता लिखा, वो आपका चार्जर नहीं चलता क्या?
नहीं, ऑन करोगे तो चलेगा ना,
कहाँ से ऑन होगा?
उस स्विच से ऑन होगा ना।
मैं तो
आप ऑन तो कर रहे, कहाँ चलेगा वो?
नहीं, मैंने करी थी, लेकिन चलो कोई नहीं
आ रहा हूँ, मैं नीचे आ रहा हूँ।
ठीक है, और आप तो लगे हुए हो हाँ?
तो रोज ही लगता हूँ, आज की क्या बात है इसमें?
सर्टिफिकेट कहीं ले रखे हैं भैया ने तो। प्रमोशन वो
हाँ?
पढ़ाई करते रहते हैं। आप सही टाइम को यूटिलाइज करते हो तो अपना आराम से।
मैं कैसे अपना टाइम खराब करता हूँ जिंदगी का? टाइम खराब करने के लिए जिंदगी?
तभी नॉलेज है आपको सब चीज़ों का।
मैं नॉलेज की बात नहीं, मैं तो डॉक्टर साहब कागज से देख के बात करता हूँ, मैं ऐसे बात नहीं करता।
ये क्या भाई नक्शे?
हाँ, पर पुराने हैं ना,
तो इनको क्या करते हो? कंपाइल करोगे?
इनमें डालता रहता हूँ वीडियो में, बताने के लिए। तो वो ऐसे होता है, पहले काम ऐसे होता था, अब पे तो हाथ के बने हुए सारे, अब तो कंप्यूटर की दुनिया है। अब तो पुराना जमाना खत्म हो गया ना, अब तो लोग नए नए नाचने लग गए हैं।
पुरानी, लेकिन ये पुरानी किताब आपकी कोई काम की होगी?
अब काम की होगी नहीं होगी वो तो अलग। ऑन कर दो उसको, मैं भी ऑन करने वाला था, उसको ऑन कर दो आप। इतना ही है बस उसका। डॉक्टर साहब 2 बजे तो सोई होगी, तो 2-2:30 बजे। हाँ हाँ, तो वो ऐसे ही है, 3-4 घंटे सोती है वो। अभी जल्दी उठ गई होगी। हाँ, अब क्या करें, जैसा भी है ना, क्या करोगे इसमें आपको ही। अब बहस करती है ना बेकार की, वो यही बात होती है, हाँ बहस करती है, वो बहस करती है बेकार की। ऐसा नहीं है डॉक्टर साहब, ये तो पूछो मत बस, आप उसका पूछो नहीं, आप उसको बस।
ब्लाइंड हो जाता है।
हम्म?
ब्लाइंड हो जाता है।